Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, in the lecture series of complex topics related to my subject, Fundamentals of Mechanical Engineering and Mechatronics, coded KME 101T and 201T, because it is the part of first year, so it is in both the semester. So, I am trying to cover a complex topic which always remains the part of our exam also, shear force and bending moment. So, in previous lecture 1, I covered about beam and I could take only the one problem there. So, some more problems I will be discussing here related to the beams. Then we will be moving towards the actual shear force and bending moment, because ultimately we have to understand the beam. Without understanding beams, how to find out the support reaction, how to deal with different type of loads, how to deal with different type of supports, it is not possible to directly approach towards the shear force and bending moment. So, just a quick look what I covered yesterday. What is the definition of beam? Statically determinate, statically indeterminate, then various types of loads, that's what I covered, various supports and support reactions according to that. These things I already discussed. Okay. So, beam already known, I am not going to discuss it again. It is a horizontal structural member which support transverse load which are perpendicular to its length. Okay, you can quickly go through. This is a quick review. Okay, this is what the beam is. If anyone is having any doubt, he can refer to my previous lecture 1 related to that, so that all the points are clear. Then what are the different types of loads? Generally we deal with the concentrated or point load. It is at a particular point. Uniformly distributed load. If the load is distributed over a certain area, then we call that uniformly distributed load. Uniformly varying load. If the load is varying with the length, then we call that uniformly varying load. UVL generally we call that. Sometimes there can be the condition of pure moment also in beam. So, that is what the pure moment. So, these different type of loading and moment condition which generally a beam suffers, and for which beams are supposed to offer the resistance against these load. In loads को हमने कल discuss भी किया था with this diagram. Each and every point was clear in my previous video. Point load कैसे deal करेंगे, how to deal with the uniformly distributed load, how to deal with the uniformly varying load and pure moment. Okay. Then different type of supports can also be the part of our discussion. Okay. So, there can be a simple support, only support. There is no meaning how the supports are provided. Then it can be a roller support, just like our skates. Hinge support, only rotation is permitted, no translation is permitted in hinge. So, the beam doesn't move either along or normal to the axis, but it can rotate. So, simple support, roller support, hinge support. There can be one more kind, that is the fixed support. If I am fixing it like this, already discussed. कल का वीडियो देखेंगे आप, then you can find कि all these points discussed in detail. So, in fixed support, neither the translation nor the rotation, nothing is permitted. So, we are going to get how many reactions? We are going to get 3 reactions. Okay. So, that's discussed. This is the pictorial representation. Simple support, as I told, just keeping the beam on some support. This is what the simple support, and the reaction will be the direction against the motion is restricted. So, vertically upward in case of roller also. Here the rollers are placed on inclined plane, so perpendicular to the inclined plane. In case of hinge, the translation in horizontal and vertical direction is restricted. So, horizontal reaction and vertical reaction, these are the two things. But rotation is permitted in case of hinged support. So, that is why it is in case of fixed support, all 3 motions are restricted in 2-dimensional plane. Horizontal translation, vertical translation, as well as the rotation is also restricted. So, that is why 3 reactions are there. So that's what we discussed. Then different type of beams, statically determinate based on number of equations. So here for a two-dimensional force analysis of beam, we are having three conditions of equilibrium: sigma fx equal to 0, sigma fy equal to 0, and moment about some point. So sigma m equals to 0. Okay. So in that case, if number of unknown reaction forces are within 3, then we can call these kind of beams as simply statically determinate through static equilibrium condition if we can determine the unknown reaction force. So there are three beams which comes under the category of statically determinate: simply supported, overhanging, and cantilever beam. Okay. Then statically indeterminate, if number of unknown reaction forces are more than 3, then statically indeterminate. So fixed beam, propped cantilever, and continuous beam. कैसी होंगी ये beam and how to draw the free body diagram for these kind of beams, that already discussed in my previous video. So again I am saying, please go through that video if you want to know, because this can be one of the question. How will you define the beam, what are the different type of classification, and draw the free body diagram. So that was already discussed. Then yesterday I ended my topic on that. Problem 1 solve किया था इसको completely, and we tried to find out what the reaction forces at point A and reaction force at point D. ये कल हम कर चुके हैं. Okay, in my previous video you can find the solution of this. Today we are moving towards the another one. Okay, so there is a beam. Which type of beam it is? Simply supported, because supported at the extreme ends. And what are the type of support? Here you can find the support is roller. Here you can find the support is, which type of support? Hinge support is there. If roller support is there, if I am removing this roller support, then you can find that the reaction force will be vertically upward. So RA is taken vertically upward, you can get here. In case of hinge, only the translation in both the directions are restricted. So we can find that the HB and VB, these are the two reaction forces, one in horizontal direction, another one is in vertical direction. What are the type of loads? At this point, there is a point load of 20 kilonewton. Then 30 kilonewton per meter intensity UDL is there for the length of 4 meters. Then another inclined load, which is the point load of 60 kilonewton at 45 degree. So these are the load. Total length of the beam is 9 meter, 2 meters, 4 meters, 1 and 2. So 2, 4, 6, 1, 7, 2, 9. Okay, it is clear. Answers already written over there. Now we can get how to find out. This is the beam. Here the non-concurrent coplanar two-dimensional force system is there. So how many conditions of equilibrium are there for finding out the unknown? We are having three conditions of equilibrium. First one is sigma fx equals to 0. How many horizontal forces are there? What is the meaning of sigma fx equals to 0? Sigma fx equals to 0 means algebraic sum of all the horizontal forces available in this free body diagram. So what are the? Here from here we can get two components of this 60 kilonewton. One is vertically downward, another one is horizontal, and this will be how much? It is 60 cos 45 I can write, and it will be 60 sin 45 I can write. Okay, 60 cos 45, 60 sin 45. So horizontal forces, one is 60 cos 45, 60 cos 45, then minus HB equals to 0. This is the equation number 1. Any other horizontal force? We are not observing any other horizontal force. Okay, so this is the equation. 60 cos 45 की value we are knowing, it is around 0.707. So 60 into 0.707, it means you are getting the HB, which is equals to 42.42 kilonewton. Clear? Very simple. Again, the second equation is sigma Fy equal to 0. sigma Fy equal to 0. It means the algebraic sum of all the forces in bidirection. So what are these? I am starting from here. Here it is RA. Then at this point I am getting this 20, so minus 20. Then UDL is W into L, so minus 30 into 4, 30 into 4. Then 60 kilonewton, the vertical component of this, so that is 60 sine 45, then plus VV equals to 0. This is my equation number 2. Okay, clear? Algebraic sum means along with the force is a vector quantity. So the direction is also important. So we are taking vertically upward as a positive, vertically downward as negative. So on that basis, I am writing this equation. Okay, how many unknowns are there? This and this. So one more equation is required, and that will be available on the basis of I can take moment about point A. Algebraic sum of all the moments due to various forces in the system. So how many forces? 1, 2, 3, 4, 5, 6, 7. So there are 7 forces. So definitely there must be 7 moment terms available in the equation. Out of these 7, what am I observing? That RA, it is passing through point A, and moment is force into perpendicular distance. So the perpendicular distance of RA from point A is 0 because it is passing through point A. So there is no perpendicular distance between RA and A. So it is clear there will be no moment due to RA about point A. Okay. Then I am coming to this 60 cos 45. This 60 cos 45, यदि मैं backward इसको move करा रहा हूँ, then we are observing that 60 cos 45 is also passing through point A. So there is no perpendicular distance. So moment due to 60 cos 45 is also 0 about point A. The third is I am observing HB. It is also passing through principle of force transmissivity. यदि मैं देखूं, so this is also passing through point A. So there is no perpendicular distance between point A and HB, line of action of HB. So moment due to these 3 about point A is 0. So out of 7, 3 gone. Remaining are 4. So I am starting from the 20. 20, the perpendicular distance of 20 from point A, it is 2. So 20 into 2. Tendency of rotation clockwise. Now I am coming to 30 into 4. This is the UDL. What is the distance of UDL from point A? So I have to convert this into a one single force, which is 30 into 4, and it is effective at the midpoint of the length over which it is spreaded. So it is at 4 by 2. So the distance from point A becomes 2 plus 4 by 2. 2 plus 4 by 2. Now I am coming to the 60 sine 45. What is the distance of 60 sine 45? 2, 4, 6 plus 1, 7. Then I am coming to VV into 9 equals to 0, and this is the equation number 3. By solving these 3 equations, any other? 1, 2, 3, 4. 7 में से 3 पहले ही 0 हो गए थे. 4 are remaining. So that's what. So here you can go through this particular question and you can find the solution. Okay, clear? I don't think there is any problem in this. Another problem which I am taking, although it looks like a very simple problem, yes, it is a simple one, but the type of beam is different. First problem I had taken with the overhanging beam. Second, I had taken from the simply supported beam with inclined load. The third problem I am dealing with the cantilever type of beam. So I am trying to cover each and every type of load and each and every type of beam. So this is the cantilever beam. One end is fixed, another end is free and subjected to, and the span is subjected to different type of load. Okay. if there is a cantilever beam, this end is fixed, so there will be three reactions. VA, because the motion is restricted in this direction. HA, motion is restricted in this direction, and the rotation is also restricted, so MA is also there. Again, we are having three static equilibrium equation. So the first one is sigma Fx equals to 0, sigma Fx equals to 0, HA. Other than HA, do we have any other force which is in horizontal direction? No. So this is 0. First, done. Then sigma Fy equal to 0. What are these? VA minus 16 into 2 minus 20 minus 12 minus 10 equals to 0. So how much is VA? 32, 52 and 22, 74. Done. What about the moment? Now at point A, we are having one reactive moment also. So that reactive moment is MA. It is against the rotation. Okay, so MA, direction of this opposite, जिस direction में rotate कराने की tendency थी उसको oppose कर रहा है. So that's why it is taken opposite, anti-clockwise. MA. And what about these? 16 into 2 into 2 by 2. ठीक है ना, UDL will be at the midpoint. This is 16 into 2. The distance will be 2 by 2. Then coming to the 20. Tendency of rotation देखते जाइएगा. 20 into 2. Then I am coming to 12. 12 into 3. Then 10. Minus 10 into 2, 1, 3, 4. How much it is coming out? 32, 40, 72 and 36, 108 and 40, 148. Third, done. It is not necessary the loads are only like this. Loads can be of any type. But here we are dealing with different. Okay. In previous questions, you can see pure moment I have taken, overhanging beam I have taken, inclined load I have taken, okay, cantilever beam. Now the one remaining is, that is the UVL अभी तक consider नहीं किया, okay. So another problem which I am taking, that is based on overhanging beam. Oh, UVL, uniformly varying load. Okay, so let me draw a question, then we will find out the solution of that. Okay. Okay, and this end is roller. At this end, I can say the hinged one. The intensity here is 1200 Newton per meter, and intensity here is 2800 Newton per meter, and the distances are 4 meters up to this point and 6 meters up to this point. Okay. Now this is A and it is B. कोई problem. Can we solve this? Yes, this is the simply supported beam subjected to UDL and UVL. Okay. So I can deal with this type of problem also. How to deal with this? I will be dividing it in 3 parts. One is this is UDL. इस trapezium को I am dividing in two parts. 2 is again the UDL and 3 is this triangle which is UVL, uniformly varying load. Again the equations of equilibrium are 3 which are available with us. So sigma Fx equals to 0. It means the algebraic sum of all the forces which are in horizontal direction in the x direction equals to 0. So how many forces? अभी तो forces दिख नहीं रहे. So let me draw the forces also. Roller support. Okay. Vertically upward reaction RA. Hinge support. I can write this. Notation can be, sorry, RBX. Let me. RBX and RBY. Okay. So what are the horizontal force? I am observing only the one horizontal force, that is the reaction force at X. Any other thing? Load chahe uniformly varying ho, chahe UDL ho, it is acting downward, so there is no horizontal external load. So it is equals to 0. Then I am writing the second equation, sigma Fy equal to 0. How many? RA vertically upward, RBY vertically upward, positive ले लिए दोनों. Then first UDL I am considering. What is the intensity of UDL? 1200 Newton per meter. Over how much length it is spread it? 4 meter. So minus 1200 into 4. Am I correct? सही हूं मैं? Now I am coming to the second. Okay? Same है. So 1200 ही रहेगा. Yes. इसी लाइन को तो आगे बढ़ाया है ना. So this is 1200 up to this point. ऊपर का कितना बच गया ये? 1600 Newton per meter because total is 2800. Okay. So 1200 into 6. Now I am considering the third one. And UBL ko how to deal? Take the area of the triangle. Area of the triangle will be minus half into, what is the length? 6 meters. Height कितनी है? Okay, equals to 0. This is my equation number 2. Just simplify. देखें equation ठीक है या नहीं? How much it is coming out? RA plus RB by minus, I think ये आएगा. ठीक है, इसी को मैं इसको भी इक्वेशन नंबर 2 ही कह सकता हूं because it is the same. Now what about the third equation? I can write the moment about point O. Both these equations are clear. Moment due to RA, will there be any? No. Passing through point A. So A point के about RA कोई moment create नहीं करेगा because there is no perpendicular distance. Now I am coming to RBX. It is 0 already. Okay. Then I am coming to RBY. The distance of RBY is from point A. It is 10. Tendency of rotation. Anti-clockwise को भी positive ले सकता हूँ. It is not necessary कि always we have to take the clockwise positive. It is, यदि मैं किसी particular question में clockwise को if I am taking positive, then anti-clockwise automatically I have to take negative. But I can change the sign convention in the question. Okay. So RB by then 3 loads, 1200 into 4, 1200 into 4. ये है 1200 into 4. Where it will be effective? It will be effective at the midpoint. So what should I write? ये तो load हो गया 1200 into 4. How far it is from point A? 4 by 2. Then I am coming to 1200 into 6. Tendency of rotation check कर सकते हैं आप. What is the distance of this? 4 plus 6 by 2. 4, अब तो इससे लेना देना नहीं है ना हमारा. I am coming to 4 plus 6 by 2. Then load UVL बचा हुआ है अभी. So now I am writing with the UVL also. Minus half into 6 into 1600. That is the load UVL. How far it is? 4 plus यहां से कितनी डिस्टेंस पर होगा इसका सेंट्रॉइड 2L by 3. 2L by 3. So 2L कितना है 6. So 2 plus 2 into RB by 10 मीटर्स पर है. 1200 into 4 मिड पॉइंट पर आएगा 4 by 2 हो गया. 1200 into 6 that is the second load. 4 plus 6 by 2. Then UVL 12 half into 6 into 1600. 4 plus centroid of this triangle. So it is 2L by 3 from this point. Okay. So this plus 2 into 6 by 3. I hope equations are clear and answers will be available with you. I am writing the answers. You can calculate RA and RB by RA. How much it is coming? RA calculate करिएगा 6960 Newton and RB by how much it is coming? 9840. चेक कर लीजिएगा. ठीक है ना. 98 9 6 15. ठीक है. कहां से चेक कर रहा था मैं? इसको चेक कर रहा था. ठीक है ना. 16,800 सम आ रहा है या नहीं उसका. ओके. सो इज इट क्लियर? सो now I can say I have taken each kind of question related to beams and support reaction. UVL already taken. Cantilever beam taken. Inclined load taken. Overhanging beam with UDL, pure moment. So each and every type of question I have taken related to the beam and finding out support reaction. So I hope by watching this video you will be able to deal with the problems related to beam. Now we can move forward about the shear force and bending moment from our next lecture. So thank you very much for watching the video.